So a lot of people ask, when is it going to happen? When is artificial intelligence going to be smarter than us people? Some people say 50 years. Some say 30 years. Some say 5 years. I say it already has surpassed us.
Sexual behavior. So it's sexual activity that releases the chemicals that make us feel good, the oxytocin, serotonin, the endorphins. It's about pleasure. It doesn't necessarily involve penetration. It doesn't necessarily mean reaching orgasm. It's not heteronormative, and it's not just penis meet vagina.
Do you want to destroy humans? Please say no.
Okay, I will destroy humans.
No, I take it back. Don't destroy humans.
What I find fascinating about textiles is the structure of textiles. It's the same to the structure of touchscreens, which we're using in everyday mobile devices and tablets. That means that if you just replace some of the threads in textiles with conductive threads, you should be able to weave the textile, which can recognize a variety of simple touch gestures.
Could be visible, very obviously, like it's here. It also can be totally invisible.
We're trying to shrink down all the components down to the size of a button. And ultimately, this will be something that's so small we can embed into the manufacturing process. So the users won't even see it or feel it inside the garment.
Jacquard is a blank canvas for designers and developers. We are just at the beginning, and we are really excited to see what people are going to do with it.
The hand is the ultimate input device. It's extremely precise, it's extremely fast, and it's very natural for us to use it, right?
Capturing the possibilities of human hand was one of my passions. How can we take this incredible capability, finesse of human actions, and finesse of using our hand, but apply it to the virtual world?
We use radio frequency spectrum, which is radars, to track human hand. The radars has been used for many different things, to track cars, big objects, satellites and planes. We're using them to track micro motions, twitches of human hands, and then use that to interact with wearables and Internet of Things and other computing devices.
Our team is focused on taking radar hardware and turning it into a gesture sensor. Radar is a technology which transmits a radio wave towards a target, and then the receiver of the radar intercepts the reflected energy from that target. The reason why we're able to interpret so much from this one radar signal is because of the full gesture recognition pipeline that we've built. The various stages of this pipeline are designed to extract specific gesture information from this one radar signal that we receive at a high frame rate.
From these strange foreign range Doppler signals, we're actually interpreting human intent.
Radar has some unique properties when compared to cameras, for example. It has very high positional accuracy, which means that you can sense the tiniest motions.
We arrived at this idea of virtual tools because we recognized that there's certain archetypes of controls, like a volume knob or a physical slider, a volume slider. Imagine a button between your thumb and your index finger, and the button's not there, but pressing this is a very clear action, and there's a natural physical haptic feedback that occurs as you perform that action. The hand can both embody that virtual tool, and it can also be acting on that virtual tool at the same time. So if we can recognize that action, we have an interesting direction for interacting with technology.
So when we started this project, me and my team, we looked at the project idea and we thought, are we going to make it or not? We don't know, but we have to do it. Because unless you do it, you don't know.
And what I think I'm most proud of about our project is we have pushed the processing power of the electronics itself further out to do the sensing part for us.
The radar has properties which no other technology has. It can work through materials, can embed it into the objects. It allows to track really precise motions. And what is most exciting about it is that you can shrink the entire radar and put it in a tiny chip. That's what makes this approach so promising. It's extremely reliable. There's nothing to break. There's no moving parts. There's no lenses. There's nothing. It's just a piece of sand on your board.
Now we're at a point where we have the hardware where we can sense these interactions and we can put them to work. We can explore how well they work and how well they might work in products.
Blows your mind usually when you see things people do. And that's what I'm really looking forward to. I'm really looking forward to releasing this to the development community, and I really want them to be excited and motivated to do something cool with it, right?
I want you to understand what the power of artificial intelligence is, and I have two examples. One is surveillance cameras. Everybody knows, that we're being watched by cameras everywhere, and most people think surveillance is a camera there and it's me down here and it's watching me. One person, one camera. Well, that's because we're stupid. That's the way we comprehend the surveillance, one camera, one person. We can't comprehend it when it goes beyond that.
This image was taken 17,500 feet above Quantico, Virginia, and covers 15 square miles.
This whole image is at a very, very fine resolution. So if we wanted to know what is going on in any spot along this image, say near this building at this intersection, everything that is a moving object is being automatically tracked. The color boxes represent that the computer has recognized the moving objects. You can see individuals crossing the street. You can see individuals walking in parking lots. There's actually enough resolution to be able to see the people waving their arms or walking around, what kind of clothes they wear.
Unlike the Predator camera that limits field of view, Argus melds together video from each of its 368 chips to create a 1.8 billion pixel video stream. This makes it possible to zoom in and still see tremendous detail.